Okay, in 2017, today is September 1st. Hey, if you're in period 2 in 2017, I handed out the wrong packet, so you need to print off a new packet or come in on Tuesday to get this packet, and then you can do it Tuesday night since we have block day because of the Labor Day holiday. Okay, although this video is 15 minutes, it's going to take you about 30 minutes to complete because you're going to need to pause, okay? So first what I want you to do is I want you to pause the video and copy this down. For a function to be continuous, the following all must be true. So 3 things must be true. You guys, you can tell where it's continuous and discontinuous by looking at the graph. But what we're doing is we're learning the language. How do we explain it in calculus talk? Okay? So f of c has to exist. That means there's a point. So point, no point. Right there. F of c does not exist. Point. There's a point here. Another thing, you guys, you have to know that there are points on this line that some kids think that this and these 3 are the only points on the graph, but that's not true. There's a point. Everywhere there's a line, there's a point. Okay, fact number 2 is that the limit has to exist. So the limit from the left has to equal the limit from the right. So here a limit exists, but here at -3 the limit does not exist because they're going to 2 different y values. And the limit does not exist at 2 because one's going to positive infinity and the other is going to negative infinity. Okay, the other rule is that the point has to equal the limit. So here we have a limit that exists, but there's no point there. So the point has to fill the hole in order for it to be continuous. Now, kids see this and they go, okay, so there has to be a hole with a point in it. But what you don't realize is that, well, that's a hole with a point in it is as every point on here, right? Every single point on here has a point equal to its limit. All right, what I want you to do is I want you to try and fill in this table on your own, just based on what you see on the graph. I'll post a picture afterwards, but don't just copy because then there's no thinking. I want you to try it on your own, and then you can check your answers. You know what, maybe we'll just check our answers in class, all right? Now will you pause and copy this down, and when you unpause, you'll hear me explain it. So we don't really talk about when the function is continuous. That would be too boring. What we're actually going to focus on is where is it discontinuous. So we need to change the way we're thinking about this. So when there's a removable discontinuity, that's when the limit doesn't equal the y value. Let me draw a picture. That's when there's a hole, okay? So either the limit doesn't equal the y value, or let's write one more thing down. Or f of c does not exist. So there's no point at all. That just means there's a hole. But you can't say there's a hole. You have to say the limit as x approaches c of f of x does not equal f of c. Okay? A jump. Well, what does a jump look like on a graph? It's when you have one here and another piece here, so the limit does not exist. And you guys should know that an infinite limit means what? A vertical asymptote. And oscillating, we haven't really seen this, but oscillating just means to go up and down like a wiggly snake or a wave. And if you recall, an oscillating function would be sine or cosine. So you can't really find one y value if it keeps going up and down like that. All right, so we're going to go and just get into some examples. I'm going to do as many as I can without running out of time. All right. The graph of the function g pictured to the right has several x values at which the function is not continuous. For each of the following x values, use a 3-part definition of continuity to determine if the function is continuous or not and name the type of discontinuity. Here we go. At x equals 8. All right, here we go, or -8, sorry. X equals -8. Here's what every high schooler, every teenager says, hole. Okay, if you write that down, I'm going to subtract points because we cannot answer like that. You may not say there's a break. We have to use Remember, the idea is easy. We know it's not continuous there. What you're learning is how to write it in calculus talk, okay? So let's go through the three-part definition, ladies and gentlemen. At -8, does f of -8 exist? Is there a point here? Do you see a point? Yeah, it's right there at 4. So let's write that down. F of -8 equals 4. Okay. What about a limit? Does a limit exist? As we approach -8 from both sides, do we end up at one y value? Yeah, it's -5. So the limit as x approaches -8, and are we calling this f? What are we calling it? G. Oop, so I gotta fix that. Let's go back. What was the limit again? The limit is going to be -5 because that's where that hole is. And this is why we use pencil and eraser. I have an unlimited supply of this whiteout, so that's why I use pen for the notes so you can see it on the video, but you should be using pencil. Okay, the point exists and the limit exists, but why is it discontinuous? Does the point equal the limit? Does the point fill the hole? No. So we have to use this three-part definition. So we did the first part, we did the second part, but it's the third reason, okay? So since 4 does not equal -5, the limit, excuse me, g of x is discontinuous at x equals -8. And the type of discontinuity, is it removable, jump, infinite, or oscillating? And that's going to be removable. So we got to write removable. Removable right here. Name the type of discontinuity. All right, let's do another one. I'll try and do my room, show my work a little bit better. X equals -6. X equals -6. So ready? Here's what we're going to do first. What is g of -6? And what's the limit as x approaches -6 of the g of x function? Okay, so g of -6 is going to be this point right here, and this point is -7. Okay, now what's the limit? Well, as I approach -6 from the right, and as I approach -6 from the left, well, the limit from the left equals the limit from the right, and that is at -7. Does g of -6 equal the limit? Yes. So all three are true, which means, is this continuous or discontinuous? The function is continuous. Okay, so we're going to say continuous at x equals -6 because now we already did the first two statements, so we'll just finish it with the third statement. Because g of -6 equals the limit as x approaches -6 of g. Barely fit in the room there. Okay, let's look at x equals -4. So at -4, what do you notice right away? So in your brain, you may say break. Do not write it down though. Okay, do you see a break in the graph? Good, don't write it down. We just need to use calculus words, okay? So does g of -4 exist? What is g of -4? What's the actual point? -5? You agree? Okay. But the limit from the left is -5 and the limit from the right is -2. So we're going to say discontinuous, and we need a reason, not because there's a break. We have to say discontinuous because the limit as x approaches -4 of the g function does not exist. This is a jump discontinuity. Why is it a jump? Well, you can see, like, if you were writing this function, you'd have to jump to get to that piece. Okay? All right. Example 3. Here we go. It's just more of the same. Use the three-part definition of continuity to determine if the given functions are continuous at the indicated values of x. If discontinuous, name the type. So at x equals -2, looks like we're doing two parts here. What we need to figure out is, we have a piecewise function, right? If we need to figure out, do all three pieces, are they all the same? Okay, so we're just going to plug in -2 into all three pieces. So here's the top piece. Square root of 4 is 2, so -2 times 2 is -4. Middle piece. We're 2 for 2. How are we doing? Do you like our odds? This looks so crazy. Cray cray. Let's see. E to the -2 plus cosine. Kind of looks similar to our quiz, right? Our quiz review. Okay, let's figure this out. E to the -2, you guys, means 1 over e squared. Because the negative exponent means that it moves to the denominator. Now the cosine of -2 pi, really, but -2 pi, you guys, is the same as +2 pi. So let me do my little unit circle here. +2 pi would go like this, and -2 pi just means you go in the other direction, but you end up at the same spot. So what's the cosine on the unit circle? What's the x value here? It's the number 1. Anyways, what do you guys think? Is this continuous? Are all the limits the same? The limit from the left? The limit from the left does equal the point, but it doesn't equal the limit from the right, because the limit from the right is 1 over e squared plus 1, not even close to -4. Okay, so what's our conclusion here? We're going to say discontinuous because the limit as x approaches -2 of the function does not exist. And if the limit does not exist, you got to think, what does that look like in a picture? If the limit doesn't exist, one's at -4 and the other one's somewhere up here, that's a limit not existing, which means it's called a jump discontinuity. All right, let's do another one. And I'm running out of time. It looks like this is going to be it. Let's see. I'm going to do another video on 4 and 5, okay? These are super important, so we'll do another video for that. 2-video weekend. X equals pi. Here's pi. Oh my goodness, isn't this fun? E to the pi. What? Did you even know you could do that? You can. Times the cosine of pi. Okay, I'm going to move down. E to the pi, well, you guys all know that answer, right? Just kidding. The cosine of pi is over here, and the coordinate point here is -1, 0. So the cosine of pi is -1. So we get -e to the pi. Fun. That's the top one. Let me work with the bottom function. Oh, I better get this. I have a minute. Let's see here. E to the pi times the tangent of 3 pi over 4. Quickly. The tangent at 3 pi over 4, well, this coordinate point is -√2 over 2, and this is +√2 over 2, so the tangent is actually -1. Isn't that cool? Okay, so if the limit from the left equals the limit from the right, and does the point exist? Is there an equal sign here? Yes. So very, very exciting, you guys. As crazy as this one looked, it's actually continuous. Now we need to write the reason. I'm going to pause. Ready? All right, I paused it. I wrote that. The magic of TV. Copy that down. Look for another video for the next 2 examples. Good job.